There's a big difference between writing a few lines of code and designing a full-fledged software application. It can be overwhelming, not even knowing where to start. This is where the software development lifecycle, or SDLC, comes into play. So, what exactly is the SDLC? Simply put, it's a systematic process that guides the development of software from inception to deployment and beyond. The SDLC ensures that every piece of the puzzle is in place, whether it's aligning the software with business goals, meeting user needs, or delivering the final product on time and within budget. Its structured approach not only helps manage the inherent complexity of software projects, but also minimizes risks along the way. The ultimate aim: to ensure that the software development process is well organized, manageable, and delivers a product that meets the intended business goals and user requirements. In software development, a structured approach like the SDLC is more than just a guideline, it's a necessity. Without it, projects can easily fall into chaos, with teams working in silos and losing sight of the big picture. By following a well-defined process, teams can collaborate more effectively, ensuring everyone is on the same page and that the project stays aligned with business goals. One of the key advantages of the SDLC is its ability to break down the development process into manageable phases, making it easier to handle complexity. Along the way, it also provides a framework for identifying and mitigating risks before they become major issues. And then there's quality assurance. SDLC ensures that testing and validation are built into the process so the final product meets user expectations. Plus, by keeping projects on track with clear timelines and milestones, the SDLC helps to reduce delays and avoid budget overruns. In short, SDLC is your roadmap to a successful software project. The SDLC is divided into several phases, each designed to tackle specific aspects of software development. In the software development lifecycle, each phase builds on the last, transforming ideas into fully functional software. From initial planning to deploying and maintaining the final product, every step is essential to delivering high-quality solutions that meet users' needs and business goals. First, there's the planning phase. It's where everything begins, defining the project's scope, setting clear objectives, and determining the deliverables. At this stage, teams perform feasibility studies to assess technical, operational, and financial viability and lay out the roadmap for the project. The result: a comprehensive project plan, risk analysis, and resource allocation, setting the foundation for everything that follows. Next, we move into requirements analysis. This is where we dive deep into understanding what users need from the software and how it aligns with business goals. Interviews, surveys, and workshops help paint a clear picture of these requirements. And from this, the team creates a software requirement specification, or SRS, document. This SRS outlines everything the software needs to do, both functionally and non-functionally. With the requirements in hand, the team moves to the design phase. This is where the blueprint of the software is created. The high-level design lays out the system's architecture, while the low-level design focuses on the finer details of each component. The outputs here include system architecture diagrams, database designs, and user interface mockups, everything that guides the development process. Now it's time for the code. The implementation phase is where the magic happens. Developers set up the environment and start writing code, following the design specifications. Throughout, they perform unit tests and code reviews to ensure everything is running smoothly. The result is working source code, unit tests, and thorough documentation to guide future work. Before any software can go live, it needs to be thoroughly tested. In the testing phase, various types of tests, like unit, integration, and system testing, are performed to catch bugs and ensure the software works as intended. The team uses a mix of automated and manual testing to validate functionality. The goal? To deliver a tested product free of defects and ready for deployment. Once the software passes testing, it's time for deployment. Here, the team prepares the production environment, deploys the software, whether manually or using automated tools, and verifies everything works as expected. Post-deployment reviews ensure that the release went smoothly. The outcome? A fully deployed software, complete with logs and user manuals for support. And the journey doesn't stop there. In the maintenance phase, the team monitors the software's performance, fixes any bugs that crop up, and releases patches and updates as needed. This is also where new features can be added, keeping the software up to date and functional long after its initial release. Together, these phases provide a structured roadmap, ensuring the software is developed efficiently, stays on track, and evolves as needed. When it comes to software development, there's no one-size-fits-all approach. Over the years, various methodologies have been created to manage the complexity of building software, each with its own strengths and focus areas. These software development lifecycle methodologies help teams organize their work, manage changes, and deliver quality software on time. In this session, we'll be exploring three of the most common and influential models: the Waterfall model, the Agile model, and the Spiral model. Each takes a unique approach to the development process, from the structured, step-by-step nature of Waterfall to the iterative flexibility of Agile and the risk-focused adaptation of Spiral. Let's start with the Waterfall methodology, one of the most traditional approaches in software development. It's a strict, linear plan with several distinct steps. You move through each phase: planning, design, development, and testing in a fixed order. The key idea here is that you finish one step completely, get it signed off, and only then move on to the next. While this may sound structured, the reality is that it's often not responsive to changing requirements. Your customers will change their minds, and so will you. In modern software development, we need more flexibility to add features or fix bugs on the go. Waterfall doesn't support continual development. That's where more flexible methodologies come in, like Agile. Next up is the Agile methodology, a more flexible approach designed to address the limitations of Waterfall. Unlike Waterfall's strict linear plan, Agile operates in incremental cycles or iterations. Each iteration includes everything from analysis and design to programming, testing, and deployment, all packed into a short, manageable sprint. So Agile focuses on continual development, small, manageable chunks of programming, supported by continual analysis and design. This allows for continual refinement, where feedback from each cycle is used to improve both the product and the process in the next iteration. This makes it responsive to evolving customer needs and market changes. With Agile's flexibility and adaptability, teams can respond to changes quickly, ensuring that customer needs and new ideas are integrated smoothly throughout the development process. Agile thrives on collaboration and continuous improvement, making it ideal for today's fast-paced, dynamic environments. Finally, we have the Spiral model. Think of it as a combination of the Waterfall and Agile models, with an emphasis on risk management. In this approach, the project passes through multiple phases: objective identification, risk analysis and prototyping, development and testing, and planning for the next iteration, in a series of spirals or loops. Each loop tackles a small set of features and focuses heavily on identifying and mitigating risks before moving forward. This makes the spiral model highly adaptive, especially for large, complex, or high-risk projects where risk management is critical. Unlike Waterfall, Spiral allows flexibility and responsiveness, but it adds a unique layer of risk evaluation at every turn. In summary, the Waterfall model offers a clear, structured path but lacks flexibility. Agile brings the adaptability and speed needed in today's dynamic environments, while the spiral model is best for complex projects where managing risks is essential. Choosing the right methodology depends on your project's needs, goals, and constraints. We've covered quite a lot about the software development lifecycle, or SDLC. Let's take a moment to recap the key takeaways. SDLC is a systematic approach to building software, helping to organize every step from planning to deployment. It's a way to manage the complexity of projects, minimize risks, and ensure that what gets built aligns with both user needs and business goals. We also walk through the 7 key phases: planning, requirements, design, implementation, testing, deployment, and maintenance, each with its own role in ensuring a smooth and successful project. Finally, we explored 3 popular SDLC methodologies: Waterfall, which is a structured, linear approach; Agile, a flexible, iterative model perfect for projects with changing requirements; and Spiral, a risk-focused methodology for complex projects. Together, these methods show how SDLC can be tailored to different needs. Thank you for watching and diving into the software development lifecycle with us. If you found this video helpful, please give it a like and consider subscribing for more insights on software development. And don't forget to hit the bell icon so you never miss an update. Keep coding, and we'll see you in the next video.